Okay, before I send you off to do more problems, I want to do another type of example with you. It's not, we've done up to number 6 on the sheets I gave you. This is not 7 or 8. Okay, this is one that comes before 7 or 8 and that I should have added in but never thought of. It's one where you're going to send something forward on a surface, like maybe it's a hockey puck that you're hitting and giving an initial velocity. Might be a curling stone. So it's something that has a velocity forward on the ice, okay, or on some surface. Could be a soccer ball, whatever. Okay, so in this particular case, I'm going to say it's a hockey puck, and you hit it so that it's initially going 15 meters per second. Now, once you hit it and give it this velocity, there's no forward force on it, and this is always where the mistake comes in. People want to put a force forward here, but you don't go down the ice continuing to push it. You give it a one-time shot, so it has a velocity of 15 meters per second, and then it goes until friction stops it. So we have friction going back here. Right? We have Fg going down, we have Fn going up. And so the question would say something like, with a slap shot, you give a hockey puck an initial velocity of 15 meters per second. It goes down the ice untouched until it comes to a stop 30 meters away. Comes to a stop means Vf is 0. And the question would be, what's the coefficient of the ice? Okay? And I'm not giving you the mass. No, I did not forget it. I didn't give it to you on purpose. So from VI, VF, and delta D, you can find your A. Told you those kinematics equations are never going to go away. So VF squared is equal to VI squared plus 2A delta D. And you're looking for A. So subtract VI squared from both sides. And then divide by 2 delta D. So VF squared minus VI squared over 2 delta D. VF is 0, so this disappears. So it's negative 15 meters per second squared over 2 times 30. So 15 squared is 225, and the negative stays, right? It's not inside the brackets. So it's negative 225 over 60. So you're going to get an A of, I think it's negative 3.75 meters per second squared. And the negative, of course, means the puck is slowing down. It does that when it's sliding even on ice. Okay, so now that we have our A, now we can go and do our sum of the forces. So we're looking for mu, which means we need Fn, so we're going to go back to doing sum of the forces in the y is equal to MAY. This goes to 0. So in the y direction, there's an Fn minus an Fg, which will equal 0. So Fn is going to equal Fg, which means Fn is going to equal mg. But wait, I didn't give you the mass, which means you cannot find Fn. So again, your choices are give up here or say, well, somehow it must be going to work out. I'll just keep going. If you keep going, go to sum of the forces in the x direction is equal to max. In the x direction, the only force we have is friction, and it is opposing motion. So negative friction is equal to max, but I don't have the m. Okay, so I could go to my frictional force, FFR, is equal to mu Fn, and we found Fn to be mg, so friction then is equal to mu mg. And now I can take this and plug it in where friction is. So negative mu mg is equal to max. Lo and behold, what's going to happen with the m's? They're going to cancel. And I'm trying to solve for friction, so I could divide both sides by negative g. So I'll end up with mu is equal to ax divided by negative g. A we found earlier, minus 3.75 meters per second squared, negative 9.81 meters per second squared. The negatives cancel, the meters per second squared cancels, and we're left with 0.38226 for our coefficient, which means the ice has not just been Zambonied, it's actually cut up quite a bit. Might be late in the period or something. Okay, so what are the keys here? That when something is thrown forward or hit or kicked, there's no forward force once it has that initial velocity. The only force that's going to be acting on it to stop it will be friction if no one else touches it. Okay, and if you're not given a mass, and sometimes you won't be, just carry your mg, and somewhere along the way the m's will cancel, I promise. Okay, so now it's time to try some on your own for homework.